Okay, so good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before you this tutorial is Hamper Kliman. So today I come with some practice questions on limits on the graph, and to those of you that have not yet subscribed to my YouTube channel, just make sure that you subscribe and you also hit the like button, and don't forget to share. And if you have a question, make sure that you inbox me on this WhatsApp line, and I'll be able to respond to you in my own free time. And of course, we have been given a graph and we're asked to simply calculate the limits on the graph. So this is calculus, and it's very simple. It's very simple. If you went through my first video, of course, you'll be able to find this topic very simple and interesting. Okay, so we know that this is just limits, two-sided limits, and of course, a limit only exists when you approach it from the right-hand side, and also after approaching it from the left-hand side, and you meet some value that happens to be common between the two figures. Okay, so here we have been asked to find the following limits, that is, if they exist. So the first one is the limit as x is approaching -2 from the left hand side. So this negative here this minus here doesn't mean a negative sign. It simply tells you that you are approaching this limit from the left hand side. So I'll go on my graph. So the left hand side is like this, is from here. This is the left hand side, right hand side. So I'll start moving like this. I'll pretend and imagine that this is my rope. So this is my left hand side. I'll climb the rope. I begin to move like that. I begin to move like that. Then I find 2 in the x-axis. Now, if I find 2 in the x-axis, what value of f of x? Remember that f of x is equivalent to y. So what value in the y-axis am I able to find as x is approaching -2 from the left-hand side? Of course, if we reach at -2, we find that the value we are getting is simply a 0. So of course, I'll put my 0 here. Okay, we'll get to the second question. They're saying we calculate the limit as x is approaching -2. Now from the right hand side, which is a positive here. So I'm going to climb the rope from the right hand side. So I'm here. So the right hand side is this side. So I'm going to jump here. Okay. Then I'll begin to move like this until I reach where there is -2 in the x-axis. Now I reach at the hole. Because there is no connectivity here, what do? I'm going to jump like that and stand here. If I stand here, I continue moving in this way till I reach where there is -2 in the x. And of course, I discover that my value is simply 2. Okay, that's my value in the y-axis. So of course, as the limit is approaching -2 from the positive hand side or from the right hand side, my answer is +2. This tells you that the limit of this particular figure here, okay, if they ask you to find the limit, okay, the limit of -2, okay, they ask us to find the limit of -2. So what I'm going to do, let me try to remove this. Let's imagine that there was nothing there and this figure was negative. Okay, now they ask us to find the limit of -2. Now you don't even have to waste time. All you have to do is simply to look at the first figures that you found. So when you approached this value from the negative hand side, it gave you 0. When you approached this same value from the positive hand side, it gave you 2. This tells you that the limit of this particular value, negative 2, does not exist. Okay, so it's that simple and interesting. We get to D, they're saying the limit as x approaches 2 from the right hand side. This is right hand side, okay? I'll go on my graph. Okay, so I'll try to get on the rope, of course. I'm standing here and I'm moving like this, moving like this, moving like that. I find a hole here. Now remember that they want us to find the limit as we approach 2 from the right hand side. So you don't have to neglect this value. Even if you have a hole here, don't neglect the value. Instead, you have to consider it. So what is that value that we are going to find? It is simply positive 2. Okay? So I'm going to put my positive 2 here. Like that. Now, we have been asked to find the limit as x is approaching 2. What could be the limit as x is approaching 2? Okay, so to find the limit as x is approaching 2, we are going to imagine, because we don't know whether it exists or it doesn't. So let's try to imagine we approach this same limit, but this time around from the negative hand side. We see if this particular limit exists. Because a limit might exist, of course, but it cannot be continuous. You must be able to understand that concept. So to understand, here they want us to test continuity. Is the limit continuing on this particular point? So what I'm going to do, I'm going to imagine that I've been asked to find the limit as x is approaching 2 from the negative hand side of f of x. Like that. Then what I'm going to do, I'll go on my graph. Now, from the left hand side, I'm standing here. Let me go where there is 2. So I find the hole here. What am I going to do? I'm going to jump. This is fun, right? Looks like a gum. I begin to move like that. And of course, I reach where my negative 2 is. So my 2 is in the x-axis. It's here. And I discover that my value is negative 2. So of course, as I approach this limit, I discover that my value is negative 2. What does this tell you? If you approach a limit from the positive hand side and from the negative hand side, it must give you the same value for it to exist. But in this case, we have 2 different values. Therefore, we say that limit does not exist. The limit does not exist. Okay? So, in order for a limit to exist, what you calculate on the right hand side must be equal to what you calculate on the left hand side. Okay? So this is what we use in order to prove whether a limit exists. But then when it comes to continuity, you must not have a hole on the graph. What do I mean? So if you check, you are standing here like that. When you reach here, this hole, imagine that this is a drainage. What will happen if you would drown? So this is a discontinuity. But because this one is shaded, it is a closed circle, it simply means that it is continuous, okay? So as you are able to see, this is continuity. But here, there is a circle, so of course, there is a discontinuity. So you must not have a hole on the graph. There must not be any asymptotes. So this is also very important, but more is yet to come. We're yet to do as many topics and questions as we can so that you get the idea of limits. Of course, this is very simple. And if you have not yet subscribed and you love this video, please do the needful, subscribe, support the channel, comment, and don't forget to share to others. Love you so much. So in my next video, I'll be able to teach you on how to calculate limits, two-sided limits, one-sided limits using piecewise functions and some other formulas. Thank you so much.